So the next point is why the Java was needed on those days. Why not the existing technologies? So those were the days where the internet was really growing fast. All the organizations wanted to provide the services to their customers over the internet because they wanted to take the, they wanted to utilize the advantage of internet. So they wanted to provide their services over the internet to their customers. So developing the applications to be accessed over the internet is not really easy. It needs a lot of effort to develop, and along with the development, it needs a lot of effort to take care of some other things as well. So what are those other things? So if you are providing your applications to be accessible over the internet by your customers, means the application should be really fast, because some millions of people will access your applications right over the internet. So the application should serve the customers really fast. So the performance is really important for your applications. The next important requirement to develop the internet-based applications is the security. So security is really important, right? So because some millions of customers are accessing your application over the internet, so the customer's data is really important. It should be sensitive. So nobody should hack the customer's data. So security is really important in your application. If you are exposing your application over, the next requirement is the application should be distributed. Distributed means can be accessed globally, across the different geographical locations. So the next requirement is portability. What is portability? So develop the applications in one environment and deploy it in any environment across the globe. That is the portability. So the application should be, the development of the application should be simple. So these are all the demands to develop the applications to be deployable or to be accessed over the internet. To develop the applications, with all these demands, with the existing technologies like C and C++ was really difficult. Because with C and C++ we can develop the applications, but it takes a lot of effort, with their existing platform or with their existing programming model. It may take a lot of effort, or few features can't be achievable as well. So that is the reason, as that was not possible with the existing technologies or existing platforms like C or C++, the industry was in need of to create some different language or platform to address all these needs. So Java came into the picture to address all these demands by providing all those features. So what are those features included in Java which can address all these demands?
Hello friends, now I am going to explain about the Java features. These features made Java to be chosen as the best choice for developing the applications over C or C++. So let me walk you through all these features. So what are those features? Simple, robust, portable, platform independent, secure, multi-threaded and object-oriented. So let me explain all these features one after the other. The first feature is Java is simple. Why Java is simple? Because the syntax is simple. So we can develop the clean code using Java syntax, so that even a fresher can easily understand the code. So even a newcomer can easily understand the code developed by some other developer. So the learning process is easy here. So it is easy to learn by anybody, including a fresher. And the confusing and the ambiguous concepts of C++ have been removed or re-implemented in Java. So what were those ambiguous or confusing concepts in C++? The examples were pointers and the operator overloading. And it was very difficult to manage with the pointers and operator overloading by anybody while developing the applications. So those used to be called as a really complex concepts in C++. These concepts have been removed in Java or re-implemented in a different easy way, in a cleaner way. So that's why Java is simple. The next feature is Java is robust, which means Java is strong. Why Java is strong? Because it eliminates the possibility of the errors during the runtime by emphasizing on compile time error checking and runtime error checking. Error checking will happen both at compile time as well as at the runtime. Because of that, there is no possibility of producing the errors during the runtime. So that's why Java is called as robust language. The other reason why Java is robust is the memory management. So it provides a strong memory management. Here strong memory management means as a developer we no need to worry about allocating the memory for the Java program. Java runtime environment will itself will provide the memory for the Java programs, and also the cleanup activity will be taken care by Java itself with the automatic garbage collection program. So there is a program called as automatic garbage collection. We call it as garbage collector. So that will take care of the cleanup of the unused memory references in the JVM. So as a developer we no need to worry about allocating the memory, or we no need to worry about cleanup of the memory. That memory management system will automatically come up along with Java as a default inbuilt feature. Java also provides strong exception handling mechanism. Exception handling means guessing the possibility of the occurrence of the exceptions and handle those exceptions prior in advance. Instead of letting it to occur at the runtime, we can guess the possibility of the exceptions in advance, and we can handle them properly, so that while execution of your program, there is least possibility of system crash. So with all these features we call Java as robust, which means Java is a really strong language. The other important feature of Java is portable. What is meant by portability? Portability means easy to carry from one environment to another environment. C or C++ was not portable because the code generated by C or C++ in one environment, in one mission, was not easy to carry to another environment or another mission, because that used to stick to the development environment only, maybe the hardware configuration or the operating system configuration. So that the code used to be generated by C or C++ used to tightly coupled with the hardware or software environments in the mission where it got developed. But Java is not like that. Java won't depend on the implementation environment, because the code that will be generated by Java after compilation is a bytecode, and that will be executed on the Java runtime environment only. It is another layer on top of operating system. So it won't depend on the implementation environment of hardware as well as software. So it is portable, easy to carry from one mission to another mission. If you develop a code in one mission, that can be easy to carry to another mission or another hardware or another software. For example, primitive data types. So the size allocated to the primitive data types in C or C++ used to depend on the number of bits of the operating system where you develop your application. For example, if you take the primitive data types, the size allocated to the primitive data types was depending on the type of operating system or the number of bits of the operating system where you are developing your program. So the size allocated to the primitive data types when you develop your program on 32-bit operating system is different from the size allocated to the primitive data types when you develop your program on the 64-bit operating system. So it used to depend on the environment where you are developing the application. But in Java, that has been removed. The size allocated to the primitive data types is fixed in Java, irrespective of the environment where you are developing your application. So that's why we call Java as portable. The next feature is Java is platform independent. So what is this platform independent? So this is something related to portability only. So if you take C or C++, the compiled code generated from C or C++ program used to be the platform specific missions. So so if you develop your program in one type of mission, in the sense one type of operating system, that can't be executed on other type of operating system. For example, if you develop your program on the Windows mission, the compiled code generated from C or C++ programs was not compatible to execute on the Mac operating system, because the compiled code used to be generated on those languages used to be tightly coupled with the operating system where you are developing your application, means at least where you are compiling your application. But Java is not like that. Java compiled to bytecode, so which means you can carry that bytecode easily to another operating system, and the JRE in that new operating system will take care of this bytecode. So it won't be depending on the platform where you are developing the program or where you are running the program. Platform doesn't matter here. What matters here is the bytecode. So you can develop your program in any operating system and compile that program that will generate a bytecode, and you can carry that bytecode to any other operating system like Mac or Linux. There you can just run your generated bytecode on the JVM. So the JVM is a on the JRE, sorry, the JRE. So here the JRE is a separate runtime environment on top of your operating system where you are running your program. So your program or your bytecode will be executed on the JRE only. So it won't be tightly coupled with the operating system. That's why we call Java as a platform independent language system. Okay. The other important feature is Java is secure. Why Java is secure? Why not C++ or C? The reason is, in C or C++, we used to have the pointers. So a pointer means a variable which will directly point to the address location in the operating system. So that means the program used to have a direct interaction with the operating system. So it is prone for the security issues. So so we can easily hack the system using those pointers, because the pointers are directly pointing to the address locations in the operating system. So the data is not secure. But in Java, those pointers have been removed. That is re-implemented in a different way in Java. So that is the reason in Java, it stopped the direct interaction from the program to the operating system by introducing another layer called as Java runtime environment, which will run on top of the operating system. That's where the program will execute. So the memory allocation and everything will happen in the Java runtime environment only, not in the operating system. So the JRE will take care of other things like how to allocate the memory in the operating system or how to share the operating system resources. All those things will be taken care by the JRE, not by the program. So as a developer, if you write a program, you can't write anything which can directly interact with the operating system related stuff. So whatever the program that you write in Java, that will be executed and the memory allocation will happen in the JRE only. So the programs won't have a direct interaction with the operating system and operating system address locations. That is the reason Java is more secure than C or C++. So while coming to the security, Java is the best choice for developing the applications. So we can develop the virus-free systems using Java. The other feature is Java is multi-threaded. Multi-threading means running many tasks simultaneously. Multiple threads can be created to execute multiple tasks simultaneously. So all the multiple threads that are created from your program can share the common memory and resources for multiple tasks. So it will improve the performance by executing many things parallelly. For example, if you take a Word document and if you are typing something in that document, that can be taken care by one program called as typing program. There is another program which will be running parallelly, that is spell checker. What it will do is it will check the spelling of each word what you type in the document. Both will work parallelly. So as soon as you type something, immediately the spell checker will check the spelling of that word. If there is anything wrong in the spelling of that word, immediately it will highlight in the red color so that you can go back and correct it. So writing into the Word document is taken care by one program, and there is another program called as type checker. So both will work together parallelly. That is called as multi-threading system. So that is the advantage of having the multi-threading system. That is provided as a feature in Java. Feature is Java. The most important feature in Java is it is object-oriented. Java is object-oriented. What is mean by object-oriented? Visualizing your program in the form of the objects, in the form of multiple objects, is called as object oriented. So in Java, the programs what you write should follow the object oriented methodology. Everything in Java is an object. One object will communicate with other object. That means the data communication within your program will happen through the objects only. So as everything is an object in Java, it is easy to modularize your application, right? So instead of dumping everything into a single program, in Java we can properly modularize the program with the objects. So we can split the program based on the type of the objects, and we can put the related information only in each object, and those objects will communicate with each other. So the modularization will happen easily in Java, so that your code will look cleaner. It is easy to extend the program in Java because the object is because the program is modularized based on the objects, right? So if there is anything that you wanted to add to one particular object, there is always a flexibility to add more features or more data to the object. So it will be easy to extend. That means adding some new data or behavior to the object won't impact the other object. So it is easy to extend. That's all. That's all about the features of Java. These features will answer the question why the Java was needed on those days over C or C++. Let's move on to the next topic.